So in this video, we'll be covering over kernel and range of a transformation. So a kernel of a transformation is that the transformation of that matrix is equal to 0. And now let's look at some examples which will make this more clear. So here we are to find the kernel of a transformation such that it is equal to x plus 2y comma 3x plus 6y. And the first step that we have to do is convert this into the matrix format, and let's do that. So the matrix format is just writing the coefficients of x and y. So here we have x plus 2y, so it's 1 and 2, so I just wrote 1 and 2 here. And then the second pair is 3x plus 6y, and the coefficients will be 3 and 6. And after this step, then we equate this to 0 and find the rref. So here it is, see the matrix here. So we just copied this format here and equated 0, and now we need to find the rref of this. And here we just do minus 3r1 plus r2, and this is the final matrix that we get. And after this, so it's going to be x plus 2y, the first row, is equal to 0. So x is basically equal to minus 2y, and y is the variable here. So the final answer will be x and y is equal to, basically what this means, if I write it again, is this, and then we just take the y outside as a common factor, and you can write either of these, doesn't matter, but you have to say that y is any real number as is the variable here. So in this question we have two parts now, so finding the kernel, and then a question for range. So again, the first step is writing it into the coefficients, so it's going to be 2 plus 1 and then 1 minus 1. And in this question we're going to use a shortcut. So let's find the determinant. So determinant is basically is just a times d and then minus b times c. So in our case is going to be minus 3, and as this is not equal to 0, we can say that the kernel is 0 as the matrix is linearly independent. And by that I mean 1 0 0 1, so the columns are not dependent on each other, and this is a shortcut. So now let's say if we find the determinant to be 0, then you have to do the long way of finding it into rref, but this is a shortcut that you can do to check first. So in part B we are checking if 3 0, the matrix 3 0 is in the range of t, so we write it in the matrix format. And now we do the rref, and after converting it to rref, this is the final matrix. So it's going to be 1 0 0 1, and this column is all ones here. So this is in the range, and when do you know it's not in the range? So let's take an example. So here we have that the two x and y's are 0, and there's a 1 here. So what this basically saying is that 0x plus 0y is equal to 1, which is inconsistent. So if you had something like this in the final stage, then you can say that it is not in the range. But there is another shortcut also for this. Since we found that the columns are independent on each other, so we can directly say that anything is in the range, since it's going to be always 1 and 1 here. So this is the answer. So in our last question we have 4 parts. So part A is just finding the standard matrix, which is the coefficients. So let's do that. So this is the answer for part A. It's going to be 2 minus 1, and there's a trick here. So they wrote the y first instead of the x, but you still write it in the order of x and y. So the coefficient of x is 5 and the coefficient of y is negative 10. This is the standard matrix for A. So in my previous video, this is the standard matrix of the projection on x-axis as denoted here, and we just multiply this now by the standard matrix. So let's do that. So this is the answer for part B. So for parts C, we find the kernel. So let's try our shortcut again. So finding the determinant of the standard matrix is going to be 2 times negative 10 plus 5, which is negative 15, and it is not equal to 0. So we can directly determine that the kernel is 0, since the columns are independent on each other. And for part D, we are finding that if 1 and negative 5 is in the range of t, so since the kernel is 0, the columns are independent on each other, meaning that any matrix is in this range. So this will definitely give you the 1 and negative 5, since this will just be multiplied by 1 and negative 5 here, and this will give you 1 and negative 5. So if you find that the kernel is 0, then you can directly say for any range question that the range is within the kernel. So this is what you have to write, that the range of t is R2, so any vector in the range is within the range. And now the other way, if the determinant is 0, then you have to do the long way, which is this way, and then you find the rref, and you find that if any columns or rows are inconsistent.